scientific program on advancing research methodology through scientific tools and artificial intelligence, jointly organized by NIT Surat, PCE Jaipur, Nexus University South Africa, Research and Development Cell PCE Jaipur, MedTech Thinking Foundation, Fazlika India, welcomes all the dignitaries, all the coordinators, convener of the program, and the participants. This is our day 4 and session 8 of this FDP. And today's session chair with us, I would like to request Professor Ranjan Janaji, Department of Mathematics, NIT Surat, to introduce and welcome our session chair.
Yeah, good afternoon to everyone. It's our pleasure to introduce Tanmay Hajra, who recently joined SMNIT Surat as an assistant professor at Department of Artificial Intelligence. I hope that everyone got my voice. Hello.
Yes, sir.
Yeah. So Tanmay has completed his undergraduate from WBAT, West Bengal. Then he has completed his master's MTech from IIT ISM Dhanbad. Then he has done his doctoral studies at Defense Institute of Advanced Technology, Pune. His main area of interest is machine learning, application of game theory. He published several papers in international and national journal of repute, published in the international conference proceeding as well. He published a book also, application of PCA in IDs. He has completed, it is ongoing actually, sponsored project, power and space optimization in Internet of Things, system on chip, funding by MIT. He has also completed consultancy project, and he is also reviewer and editorial board member of several journals, technical program committee of several conferences. He has previously worked at IIIT Pune since 2018. Prior to that, he was assistant professor at ISBM School of Technology. Okay, so he performed also throughout his journey as a assistant professor, several academic and administrative responsibilities as well. I am not going for the details. He has delivered different invited talks, several here, and also examiner and paper setter of several university and institute within India. With this, I'll request Dr. Tanmay Hajra to deliver this talk. Tanmay, are you there?
Yeah. Am I audible?
Yeah.
Am I visible?
You are not visible.
Okay.
But you can share your screen. That may work.
Okay. Anyway, I think there is some issue with my video, so we have to start. So, I think my voice is audible, right?
Yeah, your voice is audible.
Okay, fine. Hope my screen is visible.
Yeah, your screen is visible.
Okay, so first of all, thank you. I must thank to the organizer of this FTP program, and I wish all the best to the organizer for organizing for a successful FTP. So this session is on deep learning. So I assume that my voice is audible to all the participants. And
can any other confirm? Yeah.
Yeah, thank you. So this is a very interesting topic on deep learning. Because nowadays people are very much crazy about data science, machine learning, deep learning. There are so many, allies areas are there, and there are so many academic programs, certification courses are offered by different institutes or edutech organizations, and even there are a lot of opportunities in industries and R&D sectors. So definitely that's why the topic is very much significant.
Tanmay, we are getting the screen of Zoom actually. So if you give
okay. So
yeah, PPT. That is so.
Yeah. So that's why the topic is so important, and nowadays this topic is not limited to computer science or artificial intelligence department. The applications of this particular area is almost in every domain. It is not only computer science or AI. It has lot of applications in the field of electronics, aerospace engineering, finance, accounts. So in every field, agriculture, just if you take any name, so there is an application of deep learning or machine learning, or we can say applications of artificial intelligence. So, I mean, artificial intelligence is basically a very broad area, and it has so many sub-areas. So machine learning is one of them, and deep learning is an extended part of machine learning. When you talk about artificial intelligence, because before jumping to the main topic, deep learning, I thought I should give a background of this particular area. So that's why I'm discussing this part. So when we talk about artificial intelligence, automatically another term comes into the picture, that is human intelligence, and how it is different from artificial intelligence. We are working with high-end computational devices. We have developed so many deep neural network models and all, and that solve various real-life problems, and there is no doubt. But still, we are way behind than human intelligence, where in certain scenarios artificial intelligence is far ahead than human intelligence in terms of computational time. So if I talk about some operations, I mean, to compute some mathematical expressions, or to compute something that humans requires a lot of time to compute and to give the results, where the general computers or even the artificial intelligence various algorithms can give you the results in microseconds. But when you talk about innovation, when you talk about logic, when you talk about creating something new, and in that particular area, human intelligence is far ahead than artificial intelligence. I can give you a simple scenario why, I mean, where human intelligence strongly dominates artificial intelligence. Just imagine a baby is born, he grows up, he learns a language, he learns so many things, he specializes in a particular area, and he is so good that he becomes he or she becomes a renowned scientist, and he is awarded Nobel Prize. Just imagine a hypothetical scenario. But if we talk about computers or artificial intelligence, if we train a particular system, even after a lot of training, after a rigorous training process, it is not possible as of date, till the date, to create something new which does not exist. The system should create it. So we cannot even imagine that we can create a system that learns a particular language, like any language like English, French, Hindi, any language. And he is so good. I mean, the system becomes so good. It creates some new things in the language. It creates some novels on a particular language, and based on that novel, the idea of the novel or the philosophy of the novel, the system may be awarded Nobel Prize. I mean, we cannot imagine it at all. Even today it may be a matter of laugh, that is a bit irrelevant. But when you talk about human intelligence, and when you compare with human intelligence in the innovation part, the artificial intelligence is far behind than human intelligence. But yeah, in certain scenarios, doing some classifications, finding something, sometimes human mistakes. I mean, there is a high chance of doing mistakes of classifying a particular object. There is a high probability of doing mistakes, but the accuracy, the level of accuracy for artificial intelligence models are better than the human intelligence model. So, but the journey continues. I mean, the journey of artificial intelligence started long ago, and then I mean, when you talk about machine learning is nothing but how a machine can learn from existing data or historical data. That is nothing but machine learning. But machine learning is nothing but applied statistics. This is just like a old wine in a new bottle. It's just renamed of applied statistics. And lot of things have been done in this particular area. Now, when you talk about deep learning, then this is definitely comes under the umbrella of machine learning, but it shows tremendous change or improvement in the accuracy level if we compare with machine learning. And that's why a lot of researchers or academicians are working in this particular area. Deep learning is just part of machine learning, or you can say the extended part of artificial neural network. Artificial neural network belongs to the topic of machine learning or belongs to the subject of machine learning. Deep learning is just extended version of artificial neural network. So that can work on large scale data or bulk data, and it can perform better results as compared to other machine learning techniques. So that's why another name of deep learning is intense learning. How quickly a machine can learn. Otherwise, when you talk about big data or big data analytics, when you deal with large size data, just imagine social network data. In every second, a large scale of data is generated in a particular social network platform. Just imagine how large it is. So it's not possible to handle such type of or analyzing something on this large scale of data with simple computational devices or simple computational algorithms. So that's why deep learning comes into the picture. Deep learning or intense learning, that machine needs to learn quickly. That is very important. So now coming to the definition part of deep learning. So deep learning uses artificial neural networks to perform complex computations on large amount of data. So these deep learning models, there are n number of deep neural networks are there. Different types of models are there. So they are ultimately artificial neural network models, but it is different from conventional artificial neural network models, because the ultimate goal of deep learning is to find or is to explore or find results with high accuracy and with limited time. So that is very important. And it can perform a lot of complex computations. Linear, it can easily solve linear equations, non-linear equations, and all. And another alternative definition of deep learning is a type of machine learning based on artificial neural networks in which multiple layers of processing are used to extract progressively higher level features from data. Because when you talk about data, the data can be anything. Image can be data, video can be data, it can be an Excel file, it can be a CSV file, it can be some messages, some social network chats, some Facebook comments or social network comments. So they all are data. Even there may be a blog, and a lot of people put comments on a particular agenda. So we can extract those data. So data may be structured or data may be unstructured. So that's why data needs to be pre-processed first. So that is very important. Now we have to, before doing the classification or before identifying something, we need to understand the data. That is very, very important. And secondly, each and every data is associated with certain features or parameters. So we have to identify those features or parameters. And we have to extract the informations from the data. Because just let's take an example of a particular data of Excel file. Okay, so that is a tabular data, right? Which is having m number of rows and n number of columns. And I assume those columns are representing different features or attributes. And in many, I mean, in several times, you might have observed that so many components or so many attributes or features are there which are not very much relevant or not important to make the prediction. So either what we can do, either we can simply remove those features if they have no significance in this in our prediction model, or even we can assign some weight for different attributes. That is another possibility. So that's why extracting the features is very, very important. Okay, and the deep learning models can perform this task with, I mean, in a progressive manner, but their behavior, their way of working are different. And a lot of deep learning models are there. The journey started almost 15-20 years ago. I mean, the deep learning journey. And the area of artificial neural network explored almost 80-90 years ago. So it's a long journey. Now, when you talk about deep learning, so why deep learning? That is very important to understand or to know. Why deep learning? Why not machine learning? Why not other computational algorithms? Why this area is so important nowadays? So we have put some important points to justify the significance of this particular area. The first one is minimize the feature engineering requirement, because it extract the features or it extract the significance of the features in a progressive manner. So that's why it automatically reduces the efforts of data preprocessing part. Second, maximize the performance to classify the objects. I have already mentioned that deep learning models, it is observed that in many applications or in most of the applications, deep learning models perform better than the other machine learning models. So performance is another very important factor or key factor why deep learning. Third, maximize the accuracy to detect abnormal patterns. That is another very important thing. Accuracy, precision, recall. So these are some terms which are associated with performance evaluation of any particular model, and minimize the cost of development. So we have to build some model that can solve versatile problems. Okay. Now there are different types of deep learning algorithms out there. So we have picked few of them which are very important. There are many. So we have picked few of them. So convolutional neural network is a very, very important deep neural network, which is mainly popular for image and video data, but it has other applications too. Next, recurrent neural network. Recurrent neural network is mainly used for time series data or historical data, like predicting or weather forecasting. For weather forecasting, we use the historical data, which is timestamp based, right? So that is very useful, recurrent neural network. Generative adversarial network is one of the most significant deep neural network. I can tell this is one of the most path-breaking work done in last decade in this particular area, generative adversarial network. This was introduced by Ian Goodfellow. I think he is now the professor at Carnegie Mellon University. Then deep belief network is another deep neural network, another type of deep neural network. Then RBM, restricted Boltzmann machine, is another deep neural network. Autoencoder is another deep neural network, and we'll give some overviews on this particular deep learning algorithm, because convolutional neural network is itself so vast that it now becomes a particular subject, because lot of architectures are there in convolutional neural networks. So in this stipulated time, we can give you some overviews on this deep learning algorithm. Now, before discussing this algorithm, we need to know the history of this particular area. So deep neural network is an extended version of artificial neural network, and the first artificial neural network was developed almost 80 years ago in 1943, where neurophysiologist Warren McCulloch, that is a very basic model which is called McCulloch model, and mathematician Walter Pitts created a model using neural network for an electrical circuit. Then, the journey started in 1943, so it's a continuous process. Almost an 80 years journey, but I have picked few of the important milestones achieved by different researchers in different time period. So in 1958, Frank Rosenberg designed the first artificial neural network, which is called perceptron or perceptron model. So perceptron model is a very basic artificial neural network model which does not have any hidden layer, which there is a simple input layer and one output layer. You give some input and you get some output. So that's simple or basic artificial neural network. Then in 1952, John Hopfield suggested creating a network which had bidirectional lines similar to how neurons actually work in human brain. In 1986, neural network used the backpropagation. That is another path-breaking work in artificial neural network. How we can minimize the error of artificial neural network with the help of backpropagation model. So it's a repeated process. Now in 2006, so almost 15-16 years ago, this particular area was introduced, which is called deep learning. So that was introduced by one of the most popular, famous, researcher in this particular area is Geoffrey Hinton, who is a professor of Carnegie Mellon University. So who introduced deep learning? And a number of contributions, path-breaking contributions, are done by Professor Geoffrey Hinton. Now, another milestone was achieved in 2012 by Google Brain, a deep neural network created by Jeff Dean, which focused on pattern detection in images and videos. That is another path-breaking work. AlexNet is another convolutional neural network architecture which won the ImageNet competition. That is a global competition. ImageNet competition by a large margin in 2012, which led to the use of GPUs and CNNs, convolutional neural network. Now, DeepFace was introduced in 2014, a deep neural network created by Facebook. They claimed it can recognize people with the same precision as a human can. So, which itself a great achievement. Now, DeepMind, introduced in 2014. In 2016, it managed to beat a professional Go player. Okay, who is in 2014 actually it beats the world's second best Go player, and in 2016 it beats the first or the champion player human Okay. Now, in 2014, GAN was introduced by Ian Goodfellow. So GAN is a popular network. It's a generative adversarial network, and it can create similar type of images from other images, or it can create fake images, or you can even train your model by comparing original images with fake images. So we'll discuss in the GAN model that it's a beautiful concept. This is based on a two-player zero-sum game, where the first player is the generator and the second player is the discriminator. Generator will generate fake samples, where the discriminator needs to determine whether that received sample is a original sample or a fake sample. So in that way, the machine learns, the machine is trained. OpenAI was introduced in 2015. So this is a non-profit organization created by Elon Musk and others. ResNet is another convolutional neural network architecture introduced in 2015. UNet is also a convolutional neural network architecture. Uh, I mean, in lot of applications in the biomedical image segmentation. 2016, AlphaGo beat the world's number second player at Go game, beat the number one player in 2017. So it has versatile applications in different areas, starting from self-driving cars, Amazon Alexa, chatbots, recommender systems, and many more. In every field nowadays there is application of deep learning. Now, what we have discussed so far, that is, the history we have discussed so far is based on how different models evolved with time. But at the same time, research requires in the model part and as well as in the hardware part too. So GPUs and the Google Tensor Processing Unit introduced in 2016, NVIDIA Tensor Cores introduced in 2017, Intel Nirvana Neural Processor 2017. NVIDIA is very much popular for GPUs, Graphical Processing Unit. Okay, and there are so many, GPUs are there, starting from P100, V100, right? Titan GPUs, DGX1, DGX2, I think DGX3 is also there. So they are more robust computational GPUs that can be used to perform different complex calculations in a small span of time. Now, people are taking help of GPUs in through cloud environments like Amazon AWS services. There are other services that are also there. So Amazon AWS is one of them. So NVIDIA produces. It has the maximum market control in GPUs. Almost, I think, 80 to 90% market. Supplies are from the GPUs only, but there is a heavy demand from the user end. But as compared to the demand, the supply is very less. So that's why it becomes very expensive, and there is a lot of delay in getting GPUs. So one of the surveys says that NVIDIA requires a lot of time, needs a lot of time to meet the current demand. So that is just a brief history of this particular area. Now, mathematics for deep learning. What are the areas which are required to understand different deep learning models? So we can, classify into three parts. The first one is the probability and statistics. Second one is the linear algebra, and third one is the optimization theory. So in the probability statistics, we should have sound knowledge about probability, statistical inference, validation techniques, and estimating the errors, confidence intervals. So these are the sub areas we need to know, or we need to understand, or before exploring this particular area. Linear algebra is heavily used in deep learning, because either we have to use with image data or video data, or say any tabular data. So they can be converted into matrices. If I talk about an image, so that may be converted into a matrix, and we need to perform different operations on those particular data. So hugely useful for compact representation of linear transformation on data. So when you get an image, this is the raw data. So we need to convert or transform the data into a machine understandable format. So that's why it requires a lot of mathematical concepts related to linear algebra. And dimensional reduction techniques. That is very important in when you talk about machine learning models or deep learning models. As I said, that there may be a certain number of attributes or parameters which are not much relevant or significant for predicting something. So that's why those particular attributes or features may be removed from the actual data. So on what basis I can remove those features? How to decide, how to determine this feature is not so relevant, or this feature does not play pivotal role in determining the level of the data. So we have to identify those features. So there are different dimensionality reduction techniques are there. I mean, this is a very important step before the learning. That is very, very important. Otherwise, the computational cost, I mean, grows in exponential level. If I plot it with the help of a graph, the x-axis, the attribute, and y-axis, the performance of the model. So when you increase the number of attributes, it is observed that the performance of the model decreases. So if the, and as well as it requires a lot of time to make those predictions and all. So that's why dimensional reduction techniques are very much useful. There is a problem which is called cards of dimensionality problem, because when the number of dimensions increases, then the performance of the model drastically decreases. So that's why we need to remove irrelevant or non-significant dimensions or attributes or features. And optimization theory. Optimization theory plays a pivotal role in deep learning models. A lot of optimizers are used in various machine learning models and deep learning models also. So that's why we need to know different linear optimization techniques and nonlinear optimization techniques. Now, if we start with simple neural network, and if I compare with the human brains, so we are far, far behind than human brains. So in human brains, it is observed that almost 10 billions of neurons are there in human brain, and lot of computations are there in a quick time. But these next three bullet points are very important, because these are the properties of human brains: massive parallelism, connexionism, and distributed associated memory. So what is massive parallelism? So human brain supports parallel work or parallel computations. So that makes our computation, that makes the human computations faster. Connexionism, they are interconnected. So one neuron is connected to another neurons. So they are connected, interconnected. And distributed associated memory. There is no centralized memory. This is distributed but associative memory. Why it is called associative memory? because one memory is associated with another. So that's why, just I can give you one example. If I ask you to remember your old days, so you take some references. If we imagine, you take some references. Okay, in my school days I used to do with my friends. If I ask you, can you remember what you did after your 10th, that 2 year duration, what you did? So you take some references and you associate them. Okay, I used to go to my high school, I used to meet my friends, I used to meet my these people and all. There are so many memories are there and they are associated. So you refer from one to another. So in that way human brains work. So distributed associative memory and massive parallelism, that is another very important point. Now, biological neuron versus artificial neural network. So the left one shows the biological neural networks. Uh, so I'm not discussing that part in detail. So it has different, components like cell body, nucleus, dendrites, axon terminals, and one neuron is connected to another neuron. Okay. And this is a simple artificial neural network architecture where these x1, x2, x3 till xn are basically representing various inputs, and each input is associated with some weights and they are basically summed up, right? So it's like w1 x1 plus w2 x2 till w4 x4. Okay, and then we use an activation function. We convert that particular summation result into an understandable format. There are different types of activation function are there. Okay, and we can compare with some threshold value and we can make some classification. If it is greater than this, and this in the level of that particular classification will be positive or the level will be negative. So if it is a binary class problem. So this is a very simple neural network architecture. So nowadays we work with much complex neural network architecture. This is a very basic neural network architecture. Now if I talk about multi-layer neural network, so in multi-layer neural network there will be 3 layers. The first one will be the input layer, the last one will be the output layer. This is the input layer, this is the output layer, and there can be one or more than one hidden layers. So in this particular diagram it is observed that there are a couple of hidden layers and they are connected to each other. I mean, the neurons in a particular layer are not connected to each other. The neurons from one layer to another layer are, the next layer are connected to each other. Okay, so this is the simple diagram of multi-layer neural network. And this multi-layer neural network can perform different types of complex functions, or it can solve complex problems. Okay, complex real life problems. Okay, but still there is the need of deep neural network. So although we can say deep neural network is I mean part of multi-layer neural network, but the way of working or the way of extracting the features at different levels or the performance of the models are different from conventional multi-layer neural networks. Although the deep neural networks are also multi-layer neural networks, but it has some added advantages. So this is an example of multi-layer backpropagation neural network. So backpropagation neural network, what is the purpose of backpropagation neural network? So it is observed that this is the input layer. These are the hidden layers. In this particular example, there are two hidden layers, and this is the output layer. And in the output layer, if the data is the labeled data, if you are training the model with the help of level data, so you know the actual levels of the data, but based on the input, your network is predicting something. So there will be a difference between the actual value and the predicted value. So which is nothing but your error. So ultimately our goal is to reduce or to minimize the error. So that we can do with the help of backpropagation network. So again, we can backpropagate, and in every layer we can change the weight values. Here in the artificial neural network, there are two things which are very important and that needs to be updated. One is the learning rate and another one is the different weights. So there you can start with some random weights, but you have to adjust them. So you start with some random weights, that's why you may get huge error at initial iterations. So again, you have to adjust the weight values. You have to back propagate. And after adjusting the weight values, you can again check the error value. What is the error? So it's kind of a repeated process, and that helps you to minimize the error. Now, we start with some deep neural network architecture. So one of them is randomized Boltzmann machine. Randomized Boltzmann machine belongs to the family of Boltzmann machine. So Boltzmann machine is nothing but a complete graph, where the restricted Boltzmann machine are basically k-partite graph. So it can be used to perform different type of tasks, or it has several applications. One of the very popular application is the recommender system that can be developed with the help of restricted Boltzmann machine. So there is a visible layer, there is a hidden layer, there is an input layer. Okay. In the next slide, we'll see a diagram of restricted Boltzmann machine. So restricted Boltzmann machine technique used for feature selection and feature extraction. It is a type of generative model that is capable of learning a probability distribution over a set of input data. And it is crucial in the era of deep learning for dimensionality reduction, classification, regression, and many other tasks. So this is a simple example of restricted Boltzmann machine. So where this is the hidden layer, this is the bias unit, this is the visible unit. So visible units, if you see, these are some movie names, Hollywood movie names like Harry Potter, Avatar, Lord of the Rings 3, Gladiator, Titanic, and Glitter. Now, based on the user responses or audience responses, we have to classify that. We have to classify these movies in different genres, maybe entertainment type or maybe action type. So this Gladiator, Lord of the Rings, this comes under this action type, and Harry Potter, these are some different categories, maybe entertainment, Titanic, glitter. So this belongs to a particular genre. So the machine needs to classify based on the user responses. So that is based on the probability distributions. Now, if I talk about convolutional neural network, so it has lot of applications in the field of image and video. So when you capture a particular image, then and say, we can perform different types of tasks after collecting or after capturing a particular image. You can you may be asked to to identify a particular object in a particular image, or the location of a particular object in a particular, or you may be asked to classify different types of objects in a particular image. Similarly for video data too. The video data is nothing but a series of frames, right? So a convolutional neural network can have tens or thousands of layers that each learn to detect different features of an image. So filters are applied to each training image at different resolution, and the output of each convolved image is used as the input to the next layer. So here two operations, three main operations are there. One is the convolution operations, okay, This is the convolution. I mean, this is an architecture of a convolutional neural network, simple architecture of convolutional neural network. So one is the convolution operation. Okay. Next one is the pooling. If you see this diagram, there is a convolution layer and there is a pooling layer. And these operations are performed repeatedly till this becomes a fully connected layer. Okay, and there can be a number of intermediate layers are there. And we use some filters. I mean to identify a particular object. There are different types of filters are there. So the filters can start as very simple features such as brightness and edges. It may be horizontal edge, it may be vertical edge, and increase in complexity to features that uniquely define the object. So I mean, it may be a handwritten digit or it may be a handwritten alphabet. So now the machine needs to identify or needs to classify that particular digit or that particular alphabet, which particular digit or alphabet it is. So if I talk about digit, so it means that particular problem having 10 class problem, 0 to 9. There are 10 possible classes are there. Now the machine needs to predict which particular digit it is or alphabet it is. If the machine is going to predict the alphabet, then there are total 26 English alphabets are there. So which particular alphabet it is? So the machine needs to understand or needs to learn that which particular alphabet it is. So that's why you need to scan the entire image. So which is very important. You need to scan the entire image from the beginning to the bottom or from the top to the bottom. So convolution operation is a very, very important uh, operation which is performed in CNN models to scan the image, to scan the entire image. Okay, and then the pooling layer, the task of pooling layer is to find out or to determine the most significant features. Ultimately it is extracting the significant features, and that is happening repeatedly. So if you see this example, so this is convolutional layer 1, this is pooling layer, again convolutional layer 2, pooling layer 2, and it may repeat for n number of times. And the last layer is basically the fully connected layer. So although this is the incomplete image, so the fully connected layer may be associated, I mean the last layer should have 26 nodes A to Z. Now the machine needs to predict which particular digit it is. Okay, so if my machine or system properly understand or properly learns, then definitely the probability of a node will be the maximum node. Now recurrent neural network. A recurrent neural network is a type of artificial neural network which uses sequential data or time series data. It is mainly useful for time series data like weather forecasting, is one of them. Stock market prediction, which is, a near to impossible problem, but various time series model shows some decent result, not very good result, decent results. So, because so many factors are associated in stock market predictions and all, so many, there are so many factors are associated. Sometimes they are directly involved or indirectly involved, so it is very difficult to predict such things. Okay, so these deep learning algorithms are commonly useful for ordinal or temporal problems such as language translation, NLP problems, speech recognitions, text. Even if you see, sometimes when you write something in your chat box, it predicts something, the next word it predicts for you, right? So those are some examples of deep neural network models. Speech recognition, similarly, if you trained with your older speeches and then if you deliver a new speech, then your machine should be able to predict the speech is yours. So that is another application. So that is very basic architecture of recurrent neural network. So which is a continuous process. If you see this diagram, so this is HT-1. This is the hidden layer. This is the input layer. This is the output layer. And after, if I just assume the HT node, okay, the input comes from the time t, and also it considers the output of its previous layer, and based on these two, it predicts the output for this particular layer, which is OT. Okay, so it's a continuous process. It has certain advantages and certain disadvantages. So LSTM, long short-term memory, GRU, gated recurrent unit. So these are some very popular recurrent neural network architectures. The LSTM belongs to the family of RNN, which gives better results than RNN in many scenarios. So LSTM, long short-term memory, it is a special kind of recurrent neural network architecture capable of learning long-term dependencies in data. It eliminates the shortcomings of the recurrent neural network architectures. So LSTMs are predominantly used to learn, process, and classify sequential data, because these networks can learn long-term dependencies between time steps of data. The problem is in recurrent neural network architecture, if I consider 1 lakh times that value of t equals to 1 lakh, so when I'm making the predictions at h1 lakh, at t equals to 1 lakh, at that time it considers the all old inputs too. So again, the machine needs to memorize or go back to from 1 lakh timestamp to 0th timestamp. So it requires a lot of time. So it's very expensive, and also it gives the results with high delay. So that shortcomings are eliminated in long short-term memory. In long short-term memory, what exactly happens that the data which are frequently used are stored into the memory cell, and which are not being used for a longer time are removed from the memory cell. So when that particular data is again required, that will be again updated into the memory cell. That is the idea of LSTM. So as a result, it reduces the computational cost and it gives better results. So LSTMs are predominantly used to learn, process, and classify sequential data, because these networks can learn long-term dependencies between time steps of data. So common LSTM applications include sentiment analysis, language modeling, speech recognitions, and video analysis. This is a simple LSTM cell. There can be multiple cells and multiple layers that consist of such type of cells. So if you see, there are different components are there in each cell, and different operations are being performed in individual cells. Like input vector xt is represented by input vector, memory from previous block is represented by ct-1. So different representations are there. So sometimes certain data is removed from the memory cell, some data is updated in the memory cell, and some data is continuously being taken from the previous cell. Okay, so that drastically improves the performance of the model. Now, generative adversarial network is one of the most path-breaking work in the last decade. So GAN is a deep learning architecture. It trains two neural networks. It's like a two-player zero-sum game. There is discriminator and generator. The task of generator is to generate images based on the existing image. So ultimately, it creates fake samples. And the task of discriminator, it compares with the original image and the fake image, and it's a continuous process. Now, when it receives the particular fake image, then it needs to distinguish that whether this is a fake image or an original. So the generator is trained with the original images. Now it needs to distinguish that whether this is the fake image or the original image, or fake samples or the originals. So to compete against each other to generate more authentic new data from a given training data set. And it has a lot of applications, like it can be used to generate synthetic data. When you are having very small scale data, but you need to generate more data, so that new data may be generated with the help of GAN, or that is another application. It may be used to create new data, and as well as to train the model in such a way so that it can easily distinguish the original samples and the fake. So your model should become a quick learner. For instance, you can generate new images from an existing image database or original music from a database of songs. So these are some applications. So this is an example of GAN. So if you see, these are real faces. Now, this generator is basically generating images. Now, the task of discriminator is to scan or is to compare with the original image and the generated images, and it needs to identify whether it is the generated image or the real image. So it's a fake data or the real data. So autoencoders is another deep neural network model or algorithms which is primarily used for unsupervised learning tasks such as dimensionality reduction, data compression, feature extraction. This is heavily used for data compression and even dimension reductions too. Uh, Principal component analysis, LDA. These are some. These techniques are also used to compress the image or to reduce the dimension of a particular image. But these transformations are linear transformations, whereas the transformations in the autoencoder, as it is a neural network architecture, so naturally the transformation of the data is non-linear in nature. So the similar type of task may be performed in with the help of nonlinear functions, with the help of autoencoders. So they learn to reconstruct the input data and capture its essential patterns, making them useful for anomaly detection and image denoising tasks. An autoencoder learns two functions: an encoding function that transforms the input data, and a decoding function that recreates the input data, and a decoding function that recreates the input data from the encoded representation. In the next slide, we'll see one diagram of autoencoder. So this is the input data and this is the output data. So in the encoding stage, if you see, ultimately from the input data we are generating a code. So in every iterations we are reducing the data or losing some information, and in the decoding phase we have to again reconstruct the data, or we have to extract the missing data. So data compression or even data creation can be done with the help of autoencoder. And there are different types of autoencoder architectures are there, like stack autoencoder, sparse autoencoder, and they are used for different purposes. Now these deep learning models for various problems. So they are bit domain specific, like computer vision problems. GANs and CNN, generative adversarial network, and CNN models are heavily used for different problems under computer vision domain. Similarly, for natural language processing, for such type of problems, BERT model, attention model, a memory network, one-dimensional recurrent neural network, long short-term memory, gated recurrent unit, CNN models are useful. for natural language processing problems. Now, advisory attack detections are again can be solved with the help of GAN. Object detections can be done by YOLO model. Now, semantic segmentation problems, mask RCNN is very much useful. Fast RCNN, faster RCNN, they are very useful. Image classification, CNN models are heavily used, identifying a particular object in a particular image, or classification of images, or classification of objects in a particular image. So they can be, solved with the help of different CNN models or architecture. Sequence problem predictions like RNN, LSTM, GRU. Sequence problem predictions or time series model. So these are all RNN, LSTM, GRU are mainly useful for time series data. Linear problems modeling and analysis, conventional artificial neural networks are useful for linear problems modeling and analysis. Now, there are various tools and languages for deep learning models. So, these are some well-known tools useful for deep learning models like Scilab, PyCharm, MATLAB, OpenCV, Jupyter, Anaconda. But most popular languages for these deep learning and machine learning models are Python and R. Nowadays people are more there is affinity towards Python because it has several advantages. So those researchers or academicians working in this particular area of machine learning or deep learning mainly use Python or for the implementation purpose. R is also a useful language. Now, different research areas in this particular field. Different areas where we can apply deep neural network model, like to detect and classify objects in images. That is one of the areas, and a lot of work have been done in this particular image, but the changes in the in the models or the new models can give better results. So one of the areas is to detect and classify objects in images. Another very interesting area is to detect and classify objects in videos. So again, this is frame by frame analysis to detect a particular image or to locate a particular image in a particular frame is another very important thing. Or even from a particular video sample, it may be required to locate different types of objects at different time stamps. So there may be a pattern recognition. There may be sorry, pattern recognitions by analyzing the video. To generate new images from to generate new images from a given set of images, that is another very useful applications where we can use deep learning models. To generate new audio from a given set of audio, to detect and classify emotion in images. That is, a lot of people are working in this particular area. From an image, you have to predict the emotion of a particular person. Even not only for a person, it may be for even for some animal. It may be cat, it may be dog. To detect and classify emotions in audio by analyzing the signals, audio signal, we have to classify the emotion of a particular person. Okay, so for that you require a lot of training data, historical data, then only, and you need to determine some feature that distinguish that basically distinguish the emotion from one emotion to another emotion, whether that person, what is the mood of a particular person, whether he is now emotional, whether he is now very happy, he is very sad, he is very energetic. from the voice you can even predict. To detect and classify emotions in audio, yeah, I have already discussed. To detect and classify emotions in text, there is a textual description, or there is a content, and from the content, the machine should be able to understand or should learn whether the text message describes some emotional message or some funny message or some serious message. So these are some kind of NLP applications we can say. To detect and classify objects in medical images, deep neural network nowadays are heavily used in healthcare, analyzing various CT scan data, CT scan images and all, for making diagnosis or for making some predictions for a particular disease, or at what stage that particular person is there in or the person is suffering from oral cancer or some say cancer in the lungs. So by analyzing the CT scan, we can infer so many things. So a lot of applications are there in the healthcare field. To detect and classify objects in satellite images, not only satellite images, even drone images. It has a lot of applications in agriculture field, that whether that particular field requires water, what is the level of water in the soil, what is the humidity, what is the condition of the crop. So many things that can be analyzed by collecting the images, or by analyzing the images, or by analyzing the videos. To detect and classify objects in speech recognition, again, it requires a lot of training data. So to distinguish the speaker, whose speech it is. So again, deep neural network architectures are very much useful for that. To detect and classify objects in gesture recognitions. So you might have seen different projects that different undergraduate projects are there, but it has several applications, especially who can speak. Okay, so with the help of different expression of fingers, they understand what the other people is trying to say. So there are a lot of UG projects are there where if you move your fingers in front of your webcam, it will show how many fingers are there. Even if there is an object in a particular finger, it is able to identify which object it is, or even a particular object is kept on a particular desk. By analyzing the video, it can tell whether it is a bottle, or it's a book, it's a laptop, or it's a pen, right? To detect and classify objects in sentiment analysis is another applications of deep learning models. Similarly, to detect and classify objects in time series analysis, to detect and classify objects in anomaly detection, whether it's a spam data, spam mail or not, the deep neural network architectures or even artificial neural network architectures may be used, whether it's a spam or not, whether this particular mail is containing some virus or not. A lot of work is being done in this particular area with the help of deep learning models. To detect and classify objects in recommender system, another very useful applications, which is nowadays used by different e-commerce sites and all, which is recommender systems like Flipkart, Amazon, Netflix, different OTT platforms, and the e-commerce sites are taking help of recommender systems. So that is beneficial for both the parties, for the buyers and the sellers. To detect and classify objects in medical diagnosis, I have already mentioned that deep neural network I have so many applications in the healthcare field. To detect and classify objects in fraud detection, even so many works are being done in predicting whether this news is fraud news or not, it's a fake news or not. So by analyzing various, by analyzing the data collecting from different websites and all, to predict weather for long term, mid term, and short term. Long term means what is the chance of rain in the month of April or May after 5 years. It's a long term prediction. For mid term prediction, whether how will be the percentage of rain in this particular summer, or short term, what will be the temperature, or is there any chance of rain tomorrow or maybe today evening. So this is short term weather predictions. So there are different types of weather predictions that there, they can be undertaken by deep learning models. These are some recent work done by us, our research team, like human face generation from textual description via style mapping and manipulation. That is, with the help of StyleGAN, we have done this. There is a textual description, and there are a lot of images are there. Now you have to map between the textual description with the image. So that we have done with the help of StyleGAN. These are the authors. We published in 2022 in Multimedia Tools and Applications. So we propose a text-to-face generative model that can produce high quality and high resolution images from a given textual description. The model is also able to produce a range of diverse images for a given description. Applications of the proposed model: criminal investigation, character generation. Sometimes you give descriptions to the police person of a criminal, how he looks like, right? So it should generate such type of images. Your system, that system should generate such type of images with the help of textual descriptions. Manipulating facial attributes according to brief textual description, text-based style transfer, text-based image retrieval. So there are many applications. Like these are some set of images, and there are some sort of, set of textual descriptions. Now we have to, the system should map that particular textual description should best fit with a particular image. So that is done by GAN. This is another applications, that is another research work published in 2022, vehicle detection under tunnel using background subtraction technique, that is published in European Chemical Bulletin in 2022. So again, it takes the satellite images, and even it takes some images from various tunnels and all, and that is mainly useful for traffic control in a particular tunnel, or whether because it is very difficult to control the traffic or to check the level of traffic in a particular tunnel. In a free way, it is very easy to observe, or to it is clearly visible the level of traffic at a particular crossing or at a particular area or a particular road, but in a tunnel it's very challenging. So we took the help from some satellite images as well as some video cameras from the tunnels for this particular purpose, to detect the vehicle, because the visibility level in the tunnel is not even good at all. So again, you have to extract the images, and by capturing the uncleared image, you have to make it understandable to the machine, that how many vehicles are there in the tunnel as per the image. So according to that, we can make some predictions that the level of traffic and all. So here we used CNN models for this image analyze, for the analysis part of the image. Okay, so these are some actually output results. Yeah. Now another application, another research work done in 2021 is applications of game theory in deep learning, published in Multimedia Tools and Applications. These are two very important area where people can work on. Game theory is an area of applied mathematics, and deep learning is nowadays known to everyone. So, how game theory can be used in deep learning models? So, GAN models are basically based on the game theory model. So that is nothing but a two-player zero-sum game, that discriminator and generator. So every player will try to win. Okay. So we have, in this particular research work, we have discussed the possible areas where the game theory can be used in deep learning models. So GAN is one of them. Reinforcement learning, in various reinforcement learning algorithms, we can use game theory and that can improve the results. Now, these are some future directions. So meta learning is one of them. Training approaches used for small scale instances. Like, I can take one example on meta learning. Like, say at our early age, I mean, a baby, when he sees the cat first time, so after watching a cat twice or thrice, he understands, okay, it's a cat, or it's a particular animal which looks like this. Okay, but for machine, if I give 3 or 4 cat samples, so the training of the machine or the learning of the machine will be incomplete, because the machine requires large size data for the training purpose. There is a thumb rule in machine learning that usually 70 to 80% data we use for training purpose, right? It's a thumb rule. But what will happen if you are having very small scale data, but your learning of the machine or the training of the machine should be sufficient? So it happens with human, but it's still, the modern research in this particular area is struggling with small scale data. It suffers from overfitting problem and other problems. So, like I took the example of a baby, a particular child sees a cat twice, thrice, or 10 times, and he knows that, okay, it's a cat. For that, his parents do not show him 5,000 cat images or 10,000 cat images. He understands it's a cat. So, how we can make, or how we can classify or identify objects with a higher level, with high accuracy, with the help of small scale data, not large scale data. Now, relation based network. Find the relationship among embeddings and objects. That is another very important area. You have to identify the relation between different attributes and other things in the data, and the level of significance of different attributes in the data. Fault tolerant deep learning models for small training data. So you have to ensure that your model is fault tolerant. It can handle large size of data, or how much data it can handle without compromising the performance. Deep learning model execution over mobile devices. That is another challenging task, because deep learning models require a lot of, computations, and that's why you require GPUs and all, right? You require high computational devices. But what will happen if I try to do the same thing in mobile devices? How we can do that? That is another area of research, and people are working where we can think of. Use of DL in neuroscience and other applications. Especially people working in human computer interaction and all, people who are struggling from different Parkinson's or different types of neuron related disease or neural diseases. Sorry, neural diseases. Is the deep neural network or deep learning models or human computer interaction research help them? That is an open research area. The artificial neural network is inspired by bioneural network, but If the bioneural network is not working properly, our deep neural network can be a substitute of biological neural network. And how we can make these connections. That is an open research area. Applications of deep learning in game theory. We have discussed in the last work, I told applications of game theory in deep learning, but there is possibilities of applications of deep learning in game theory, just opposite of it. Like, say two people are playing chess, or two people are playing a particular game, and machine does not know the rules of the game. So just by seeing the game, whether the machine will be able to understand the rules of the games, or in the future whether that machine can be a substitute of a player. That is another open research area. Extracting complete information from partial information using DL. That is another very important research area. Some industries have started to explore that particular area. Uh, like I can take a simple example. What I'm trying to say is like, say there is a big rock, and behind a rock there is a tiger, and a person can only see the tail of a tiger. Okay, so just by seeing the tail of a tiger, the person can predict, I think this is the tail of a tiger. The tail of a tiger is just 10% part of his entire body, hardly 10% or maybe 5% part of the entire body. So it means the partial information is the 5%, and you have to extract the entire information remaining 95%, whether that is the tail of a tiger, or it's a snake, or some other object. So extracting complete information from partial information using deep learning models. Deep learning in quantum environment. Now there is a transformation in computation, that is switching from conventional computational devices to quantum devices. So similarly, if we move from computational devices to uh, quantum devices, then we have to think the machine learning models and deep learning models in quantum environment also, because it drastically reduces the computational time. So how we can develop such model in quantum environment? So very few research work have been done in this particular area, but there is a huge scope for doing research in deep learning in quantum environment. Now, what are the challenges we are facing? So one of the challenges is time consuming process, because mainly deep learning models are used in large scale data. Then it is used in large scale data, so definitely it takes a lot of time. So definitely GPUs are faster than CPU. So one of the part is you have to come up with improved deep learning models, and another one is the hardware improvement in the hardware part. Otherwise it handling different real life problems may take months or years to make a prediction. Using small scale data leads to overfitting issue. Again, these models are observation based models. So it requires a lot of data, large scale data for training purpose. So that is itself a problem. Observation learning, as I mentioned, observation based learning. It is not trying at the initial of this talk, at the beginning of this talk, I told you the fundamental difference between human intelligence and the artificial intelligence. There is nothing, no innovation in learning. It is only learning. It is only trying to learn the patterns or to make some predictions, but it is not doing any kind of innovations, doing something new. The machine fails. Use large scale data for preprocessing. That is another challenging task. Training and processing of large data is costly. Yes, of course. That is another very important thing. And hardware constraints and cost. So that's why many people are taking help of cloud-based solutions, because these hardware devices are in crores. So it's very difficult to, doing research at individual level without any external funds, because purchasing a high-end GPUs is very, very, very expensive. So that is another very important thing. And day by day, the requirement of high-end GPUs are increasing. So as I said, that there is a huge gap between demand and supply. So that is another challenge in, those people who are working in this particular field. So these are some references, although I took some help from internet. So this is absolutely for academic purpose. Okay, so that's all from my side. So if you have any queries, so please let me know. Am I audible?
Yes, sir. Yes, sir.
Okay.
Yes,
Okay,
sir.
so yeah.
Yes, sir, you are audible.
Okay, okay. So
Thank you so much, sir. And on behalf of the organizing committee, sorry, sir, there is some technical issue. On behalf of organizing committee, am I audible?
Yes, ma'am.
yes, ma'am.
Okay, okay, ma'am. Okay. Thank you so much, sir, for the wonderful session. And I request all the participants, please leave the meeting and join the session tomorrow at 9:30.
Please wait for the feedback link. I'm
Okay,
sure.
we are sending feedback link in the chat box. Please wait for the feedback.